So now you can see my screen and my app window, and everything is going on in that app window. I'm not going to show any fancy APL codes. Okay, so I start. It's some of you have seen some of it before, but there will be something that none of you have seen before. I'm not. It's an application called Polyomino app or Polyomino app, and it's based on dialog APL. I'm not going to show you any dialog code because it's the application about 5,000 lines of code. So and the time is too limited to go into details with that. We could take that another time if there's any interest for it. So here we see the application window, and there's some tabs up here that helps you navigate around. We are at the moment at the front page, shown here in this corner, and I'm going to talk a little about what's the movement behind this, and this is some examples of what were the primary movement, or should I say, mover on this subject. It was in order to make puzzles. And here we see some puzzles with polyominoes. And here's some more of them, and still some more. And the problem is that you have a box or a frame, and then you have some pieces like a normal puzzle, and then the problem is to move the pieces into the box. Contrary to normal puzzles, this can be done in many ways. This puzzle has 16,146 solutions, but if you try to do it manually, it will take maybe half an hour or an hour to put them in. So that's where the computer comes in. It's about helping you to solve the puzzle. And we dive into the application by choosing solving puzzles. There's three major sub applications in this application. And that's about solving a puzzle, designing a puzzle, and then there's a laboratory for investigation of these matters. We return to each of them. I talk a little about solving. When we're talking about solving such a puzzle, it could be either manually, automatic, or we could replace some solution we have found earlier. And if we look into the solving process, manual solving, we see here a box. It's a three-dimensional box, and up here we see the puzzles, the pieces that is supposed to go into the box. So we can take an example. Here we have a piece, and it moves around in the possible positions, of which there are 128. And when I decide where it should be, I point to a position in the box. And in this way, I let the piece move around, and then I introduce some fixed points. I can do it in advance, and then fix it further when I like the piece in that position. I will return to that later. First, I will give you an overview of the application. We have now been down into the solving process. We were down here, and then we could go to the design puzzle. We'll do that in a moment. And then we could go to the lab, and I will do that for now. In the lab, there's 3 major things you can do. You could go to the library, or you can use the generator, or you can go into the X-ray machine. The library is a place where a sort of database for all the polyominoes that's available to this system. And in this table you have 2 dimensions. The one is volume and the other is dimension. So if, for example, we take some polyominoes of volume 8 and dimension 3, we can see that down here we see the envelope boxes, and if I point to one of these, we can see we have chosen the box 233, and then we can see some examples of this. And if you choose one of them, you can see that they fit into a box that is 2 times 3 times 3, 3, 3, and 2 in the depth. In order to manufacture these polyominoes, I have the generator. We won't go into that today, but it's obvious that if you want to generate these many thousand of polyominoes and have one unique of each, then you have to have a generator, and that's where the generator comes in. It's here. We won't activate it today, but maybe another time. I go back to the front page, and here we are where we left it. And as soon as you have defined puzzle or solve a puzzle, you can wish to design another puzzle. And this is a designing process that contains taking a collection of pieces and tell how many you want of each piece, and assign a name to it. So it's an association between a collection of pieces and a box where the pieces should fit in. And if we go into it, we do that a little later. After that, we can talk about making a collection, because it should be pretty obvious that once you are in the design process and want to make a puzzle, there's many possibilities for choosing the pieces, because they could be anywhere in the library. shown over here. Any one of these pieces could go into a puzzle. So if I so that you will be in need to make a collection, and you can do that by visiting the library in this way, and then you can see there's another way to show these pieces in the, and then you can select some of the pieces and you can visit them, and then you can see the selected pieces, and you can combine them with other collections, for example the corner pieces from the first page, and there you have a collection of 7 pieces. They have a volume of 31, and you can deselect, of course, some of them, go back and choose some other ones, and in this way you can build a collection. And then you give it a name and save it, and that's it. Now we go back to the front page and to solving a puzzle. Maybe I should just make a few words about who I am and how I got into the APL world. Here you see the table of the library, the numbers, and here's the order itself, and here's a few data about me. I've been working with the APL for quite some time. I met the first introduction was on a pub in Copenhagen, where I met a guy named Henry Budzewski, and it was around 1975, and it shows now that his son Adam Budzewski works for the Dialogue now. I had a meeting with him in Toronto where I presented this application, and it was quite interesting to talk with him. I got a private Dialogue APL license in 1996, and in order to make have an APL system available, and here I defined and solved by the computer 4D polyomino puzzle. I have never worked with APL in my professional career. I have been a SAS consultant the whole of my life, or the whole of my career, to be more specific. And now I only work with APL on a private basis, and that's it about me. Now we go back to the solving process. I will start by a replay facility we have in order to introduce some of the elements. I choose a puzzle that I solved on this date last month, and it's a Soma puzzle. And here up you see the pieces that go into the puzzle, and here you see the puzzle box. It's 3 by 3 by 3, and there's 7 pieces up here. And when I replay a solution, I could either take the pieces one by one up here, and then they jump into the box. I have no choice where this particular piece could go because I'm replaying a solution that is already made. That means that every piece up here has a unique placement down here in that solution. But the thing I can choose is the order in which or where I would have the next piece to go. If I take this position, I find the piece that cover that position. And I can do next here. And if I like to see where does that piece go, I can get the answer by selecting it. And here I can either select the piece or I can point to that hole up here, and you can imagine that it will fit in here. And in this way I can present a solution. Now we will go to try to solve a manual puzzle. And later on we will solve a puzzle automatically. But first I will solve one manually. I choose the puzzle. It's still the Polyominoes. It's only in 2 dimensions, so it's only 2-dimensional pieces here. They appear 3-dimensional, but that's only an artifact by the presentation. So I can point to a piece like before, and it moves around in all the possible positions. Now there's only 64, because there's only one layer here for that. And then I can point to a position where it should be, and then another position, and then it's frozen. And you can see the numbers up here shows how many ways you can place each piece in the box, in the remaining free space of the box. These numbers change all the time, and we can see the pieces are ordered by the number of ways it can be placed in the box. So that's in ascending order. So the least possible piece is always shown out here in the leftmost position. But we go on to the piece, and as soon as I decide where it should be, it will go to that place and show the remaining position with that piece. And in this case, there was only one position to place the square onto that piece. I can choose one in advance and choose the next one, and it will present itself with that fixed point I chose before, and then I can fix the piece in a position. Similar with the next piece. You can see it flips between 2, and I want to fix it there. And then I take the cross. Of course, I know this solution, so I know what I'm doing. And then I point to a position, and it will fix because there's only one place where the cross can take that position that I pointed out with the yellow. Okay. When you play such a game here, one of the questions that arise is, are there any solution ahead of this? And in order to get an answer to that, there's a question button here. And I can ask, are there any solution ahead with this configuration. And when the lamp turns green, it means that, okay, there's a solution ahead. So I will continue. I know I'm not wasting my time totally. So I go ahead with this, with placing pieces in the box. And it could be, of course, I know there's some solution here. And I can turn the box and choose my fixed points. And you can see here it's not completely fixed, but then while it's away, I can choose another fixed point, like this. Okay, but let's take this one, and I fix it up here and fix it down here. And here we saw the lamp turns red. That's because the least placeable piece, you remember that's leftmost, has only 0 ways of being placed in this position. So here I have to backtrace. I remove the last piece in the box and try again. I could do it in this way. And here we can ask, are there any solutions? It seems so. We have 3 pieces up here. There's only one position they can be placed in, each of them. And I can ask, are there any solutions? Yes, there are solutions. So all I have to do is to select them. There's no need to say where they should go. There's only one place they can go. So I just choose them one at a time, and then we have a solution. And that's it. And we can see out here that it took 5 minutes and 26 seconds. I have 1 red lamp and 2 green lamps. Now they are up here again. You can see there's only one position. Now I can replace the whole game like this. And in this way I can see how did I solve this. Okay. Now we're going to try to solve this automatically, because we know there's many more solutions than just the one we have found. So I go into the automatic solving, and I take the same puzzle as we have just taken and solve manually, but now I want to solve it automatically. And I choose the number of solutions I want to see here. And 1E2, that's 100 solutions. And then we start the solution process. And we can see it's already done. And I can see solution number 99. In this way, I just replay ready-made solutions. I could choose solution number 90 in the same way and replay that. Okay. And I could also show all the solutions, all the 100 solutions we have found yet. And we do it here, and move it to the center here. And here you can see the 100 solutions drawn by the APL decorator symbols from the atomic vector. This is only an edit window. What you see here is text, and each of the 100 solutions are drawn by these symbols. Okay, I close that window again. And now I will show you another example of finding solutions automatically. We can choose a 4-dimensional puzzle. This one contains 27 pieces. It's a Polyominoes like before, but then supplies with the 3 4-dimensional Polyominoes that is available when we allow Polyominoes. Here we have them in all dimensions, 1, 2, 3, and 4. There's no 5-dimensional Polyominoes, pentominoes. So here we have all of them, and where the box we are going to fit the pieces in are 2 times 2 times 3 times 11. That's a 4-dimensional box, as you can see. As before, we try to find 100 solution. We do it again. Oh, there we have. Okay, that's only 19 solutions, but that will be sufficient. There's a bug here. Okay, now they found the 100 solution I sought. And we can see them here. But this is a 4-dimensional thing. We have split the box into along 2 dimensions in order to get down to 2 dimensions that we can show here. And it's the APL decorator symbols used again, but it's not very, it's difficult to interpret. Because we jump from 4 to 2 dimensions, and it's hard to see what is what, because the pieces go across the 4 different part of the box that we are showing here. In order to get over that, to get another way of showing this is to do this one. Now I choose one of the solutions and show it in this 3-dimensional fashion, but it's still a 4-dimensional object. So, but here I only need to split it up into 2 boxes, you can see the two boxes are 2 times 3 times 11. So the 4-dimensional thing is split up into 2 instead of 4 as before. Okay, and then I can replay a solution by pointing down to a place here, and the piece that covers that place will jump into the box and jump out of the list up here of all the pieces. And in fact, this is a 4-dimensional piece that we show here, and I know where the 4-dimensional pieces are. They should be somewhat down here. An additional one down here. This is the 4-dimensional pieces, and then we can you can see they go into both boxes. Some of the 3-dimensional pieces will also go into 2 boxes, or both boxes. Let's take this one up here. You saw that piece. It was a 3-dimensional piece, and it goes into both boxes, so it splits. And here's 3 cubes in one box and 2 cubes in the other box. So this is another way of showing the 4-dimensional solution. And I can choose some more of the pieces up here. And then we'll, as before, jump into the box where wherever they are should be. So, and that's about now my half hour is about to be gone. So this will be the concluding remarks, and if you have any questions, then I can take them now.
Thank you, John.
Yeah. So this was the last thing for today. So do you have any questions? Are you there?
Yeah.
Or are you asleep?
Yeah. Lost in admiration.
At Hell, in Finland, you showed it. I think you said at the end you can actually buy puzzles from shops. Is that true?
Ray was asking.
I could hardly hear.
Ray was asking you to buy these puzzles, John.
What?
John, how much do you charge for one of the puzzles? I saw you printed one on your own 3D printer. Are they for sale?
Not at the moment. Yes, I had some 3D in the puzzles. Yes. Oh, yeah. I should turn my camera on too, so we can share my webcam. That's here. Yeah. Now we are here. They are not on sale. I have only made 2 3D. I have 10 copies of different kinds of these puzzles, but I have no for sale at the moment. But maybe that's an idea if I see there's an interest for it. But by studying these these puzzles on the computer, I have found out that they are very difficult to solve. And I can show you one here. Here's one made in 3D, printed in 3D. But I have found out by studying these puzzles on the computer that they are very difficult to solve. Nothing like the Soma pieces from Piet Hein that contains only 7 pieces. This one contains 25 pieces. You saw it maybe this is a computer version of this game. By looking at the scores, and when you do the first error, I have found out that you usually make an error in the sense that no solutions ahead before you have put 10 pieces into the box. Mm-hmm. And then there's still 15 to go, and and before you find out that you have misplaced one of the first 10 pieces, you can have spent a lot of time, maybe the rest of your life. You can see how many. Yeah, you can see here how many ways that, for example, this piece can be placed in 880 ways into the box, and now it will step through that 880 ways it could be placed, and so there's a very big fan out on each step. So I don't know if you will have any. It won't be very pleasant to try to solve this without a computer assistance. Maybe it's impossible. Next month I will have the piece lent out to a guy who tried to see if he can put the pieces into the box without computer assistance. And he will have the pieces, the puzzle, in a month, and then we can see if he can solve it. So before there's any meaning to mass produce these pieces, I won't do it. Thank you for listening, and go say goodbye. Okay?
Thank you.
Thank you.
Thank you.